Welcome back. So in this video, we're continuing to talk about root finding, and particularly we're going to talk about some MATLAB functions that are available for us to find roots automatically using some of the methods that we discussed in the previous video. So the first function that we want to be familiar with is the function called f0, which it's a function that implements actually both of the methods we discussed, or three of the methods we discussed so far, as well as many others. We're not going to cover all of the ones that are implemented in this f0 function. We'll just cover some of the popular options. So here's how you use this f0 function. Here you have you call f0 and with the function, and here this function keyword here is actually a function handle, and here is your initial guess, right? So if you can request that it outputs just one output, in which case this will be the value of the root, or you can request that it outputs two outputs, in which case it gives you the value of the root as well as the function evaluated at that root, and that way you can check that it is indeed zero or very, very close to zero, right? So you can also, this would use one of these open methods that we discussed. We discussed two of them specifically, but you can also call the f0 function with the bracketing approach, and all you have to do is pass the same function handle as well as the bracket. Where the keyword here is that the key point here is that the x0 and x1 points that you're passing to the function must indeed bracket a sign change of the function. So there are many ways to pass parameters to this function, and the most straightforward one, which actually the one that is most easy to use, is to this other function call, which is called optimset, or optimization parameter set. So this outputs a structure which you then pass it to the f0 function, and then the f0 function will understand everything automatically. And there are many parameters. You pass parameter 1, you call it something, and then you pass the value. Parameter 2, pass the value, and there are many parameters. I encourage you to look at the f0 and the optimset documentations of MATLAB to do this. Because, for example, some of the parameters that you can pass are the display. When this display is set to this iterations, it will display all the iterations. These algorithms that we're describing are iterative algorithms, so for each iteration you have a new estimate, so it will display all of them. And also you can pass a tolerance, meaning you ask the f0 function, don't give up until your root is close enough to this tolerance level. Typically tolerance would be 10 to the negative 4 or 5 or something like that. That will give you a very good approximation of the root. So here's how you use this optimset function. You just call it. Here you pass the display and you set it to iteration. The function would then display, when you call the function with this options structure then, and here's an example, and this, by the way, this is how you call a function handle, right? You can define inline, or you can call just the name of another function, which is another M file as well, and you pass the options that you set before. So if you call this, MATLAB will display 35 iterations of this call. MATLAB has other interesting functions. There are thousands of functions in the MATLAB program, but with respect to root finding and polynomials, it has also other interesting ones. So it has a specific program to find roots of a polynomial, and these include any imaginary or complex roots that may arise. And the way you call it is you pass a C vector, a vector of coefficients, a vector whose elements are the coefficients of your polynomial. For example, here's an example where you declare this function. This is a fifth order polynomial, the polynomial degree 5, and the coefficients are 1, 3.5, 2.75, and so on. So these are the elements of the array that you pass, and the MATLAB will implement a special algorithm for finding roots of this polynomial and gives you the roots in this vector x. Finally, MATLAB also has a poly function, um, that that can determine um, can determine the polynomial coefficients if the roots are given. So for example, if you give the roots of a polynomial to this poly function, right? So then you will essentially you multiply the roots out and group the terms so that you have a an output which is a vector, which is in the same format where the first number here means you have x squared, second number multiplies x, and third number multiplies x to the 0 power, right? So likewise, you can evaluate the polynomial at a particular point. You declare the polynomial coefficients this way with this array, and then that means you're declaring this polynomial, and then you pass uh, this array to the polyval, and you ask evaluate this polynomial at one, and MATLAB will also evaluate the polynomial for you.